So today what we're going to do is start taking a look at some special right triangles. So we're going to look at a couple, and you may remember these from geometry. So if we have a 45, 45, 90 triangle, and what do we know? It's an isosceles, so two sides are the same. So let's say n and n. Well, what would be the length of the hypotenuse? Well, n squared plus n squared equals cn squared. So 2n squared equals c squared. And to solve for c, so we have n times the square root of 2 would be that length in terms of n. Now, 30, 60, 90, it comes from an equilateral triangle that we turn into a 30, 60, 90 triangle. So 60, 30. Now in an equilateral sides, all sides are the same. So if this was n, we cut this side in half, so it would be n over 2. And then if we needed to find this other length in terms of n, we'd have n over 2 squared, kind of like a squared, maybe we call it b squared equals c squared. So we have n squared over 4 plus b squared equals n squared minus n squared over 4. So now we have b equals n squared minus n squared over 4. Yes, then b would squared, that's b squared. N squared minus n over 4, that's kind of like 1 minus 1/4, so that would be 3 over 4 n squared. Take the square root the numerator and the denominator, so that would be, well, we'd have n, the square root of 3 over 2. So we have all these sides in terms of n. So now if we take a look here, if one thing we notice here is our hypotenuse is 1. So we knew this was n, and this side was n square root of 2. So what is n? Well, divide by root 2. So now we have n equals 1 over root 2, and we're going to rationalize this. So multiply by root 2 over 2. So n equals root 2 divided by 2. So this is root 2 over 2, side is root 2 over 2, and then this side was 1. So now when we look at our 30, 60, 90, we knew this side was n. Across from 30 was n over 2, so opposite 30, though this was 60, so this was n times root 3 over 2. Well, we know n is 1, so this side is 1 over 2. This side would just be root 3 over 2. So what does this have to do with what we're looking at? Well, we're going to take a look at some trig functions and how we can evaluate these without a calculator. So the sine of 30, if we were to draw in this angle, here would be 30 degrees. We could make it into a right triangle, and we could say, well, let's have our hypotenuse be 1. Well, opposite 30 we know is 1/2. Opposite 60, root 3 over 2. So sine, opposite over hypotenuse, 1/2 over 1 is 1/2. Now we could look at the cosine of 30. Well, our cosine of 30, it's that exact same triangle we had before. So actually we don't need to redraw it. We're looking at the cosine adjacent over hypotenuse. So we have root 3 over 2 over 1, which is root 3 over 2. If we look at these next couple here, take a look at the sine of 45. So again, 45 degrees in this first quadrant. So here's 45. Whoops. And let's say we said that this was 1. We know that these were root 2 over 2. So the sine of 45, opposite over hypotenuse, root 2 over 2 over 1. So it's root 2 over 2. Cosine of 45, that same triangle, adjacent, so root 2 over 2 over 1. So we have root 2 over 2. And then this last one, we have the sine of 60. So if we, in this first quadrant, were to draw on 60, 1, we know opposite 60 was root 3 over 2. and half, so sine O over H. So we have root 3 over 2 over 1, so we have root 3 over 2. And cosine adjacent, 1/2 over 1, which is half.